So I'm going to welcome you to the NHERI SimCenter Live Expert Tips. And in this section, we're going to introduce you to how SimCenter goes about getting building inventory using machine learning. And this is pretty much what Brailles is all about. And Barbaros is our expert on Brailles. He's a postdoc working at UC Berkeley, though he lives down in Los Angeles. Barbaros received his PhD in instructional mechanics with a minor in geotech from the University of California, Los Angeles. He worked there for a while as a postdoc, and now he's working with us. And he's currently working on our Braille software. Anything machine learning related to SimCenter is what Barbaros is responsible for. His areas of expertise include deep learning, computer vision, and big data algorithms. So Barbaros, thanks for being here, and I'll turn it over to you.
Good morning, everyone, or good afternoon for most of you, wherever you are. So my topic for today will be talking about the SimCenter software named Brailles. And really the objective of Brailles is to enable researchers, the broader natural hazards engineering community, ways of obtaining inventory data using deep learning, mainly images, and sometimes by augmenting with other metadata available online open source. So you're seeing basically two graphics here. On the left, an image segmentation where we have a model that extracts the regions in an image that would be relevant to inventory extraction. And on the right, you see this sort of like a prototype application that was done for figuring out year of construction, sort of like looking at timelines of satellite images to see how the cityscape changes and how the year of construction could be extracted. With any of these presentations, I think it's always a good idea to sort of start with a motivation. Although I think a lot of you are aware of how important this tool could be. It's good to sort of touch on that point. So when we talk about regional level loss assessment, any sort of hazards engineering application, the very first thing we start with is we have some sort of a hazard map, right? It could be shaking intensity, it could be storm surge, wind fields, depending on the type of hazard we're investigating, we would have different kinds of hazards. And those hazards are typically coupled with some inventory information, which then is assigned to typically what we call fragility functions to figure out what kind of susceptibilities are in the infrastructure we're investigating. The end result will be predicting losses of this analysis, right? So very high level, I know there's a lot more to it, and SimCenter developed tools going from the step one, the initial step here, all the way to the end. But the topic of this presentation will be really just focusing on the inventory aspect of it. Extracting attributes relevant to loss studies. And when we talk about inventory, at least for this presentation, we have upcoming tools for other sorts of infrastructure, but at least for this presentation, we're really focusing on just buildings. And the snippet of image you're seeing here is a building inventory developed for Santa Monica, California, a city in Los Angeles area, where we were able to extract the building heights and footprints and some other attributes, and by extruding the footprint up to the building height, we got these three-dimensional geometries. If time permits, we're gonna hopefully create something like this in a smaller scale. Okay, well, you might be thinking, why would I really need Brailles? There's tools like HAZUS out there. There's a brand new database that just came out, named, for instance, Natural Structures Inventory. When we have databases like these, why would I need to actually use Brailles? The answer is fairly simple. We talk about HAZUS, we talk about assessing building losses. HAZUS actually performs loss assessments at aggregations. Basically groups of buildings, and these groups could consist of thousands of buildings in one group or more, sometimes less. But in essence, really, you're getting more of an average sense of losses as opposed to sort of pinpointing where potential vulnerabilities could be. So that's the typical sort of like the HAZUS case. That's the way things have been done. HAZUS is just a absolute great software that pioneered this area. But this is you can think of this as a shortcoming or something that makes things a little bit more abstract. On the more detailed side, something such as natural structure inventory or building inventory, you will find a lot of fields, and a lot of those fields are related to loss assessment, studies. But you will also notice that in certain cases, these fields are insufficient to go in further depth. So what Brailles is really doing is it does all of this, all of this inventory generation or inventory determination at a specific building level and for an ever-growing catalog of attributes. For instance, roof shape, you don't find something for it in either HAZUS or natural structures inventory or any other really open sources out there. But with Brailles, you're actually able to get some of these attributes that are important, and it's all thanks to deep learning AI algorithms that enable us to tap into openly available images and extract whatever attributes will be necessary. And these attributes typically we don't come up with. We look at the literature, we talk with the experts to find out what will be the sort of like the useful catalog that or the catalog of attributes we would need to use. I'm not going to go into much detail of this sketch. This is just to sort of give you an idea of the scale of some of the algorithms involved. And what we typically use is street level imagery, a combination of street level imagery and satellite imagery to extract attributes. But when we talk about getting, for instance, dimension data like building height, foundation height, the height of the roof, or total window areas, these things are all dependent on figuring out the scale of objects in an image. So we have fairly sophisticated algorithms that are able to perform the necessary corrections to images to get this information. This is just sort of like a sample pipeline, and this pipeline is implemented. This is just sort of like an example of how it works. And for instance, figuring out the roof pitch, it figures out what the outline of the roof will look like, and then determines the height based on the street level imagery and couples that information to figure out the roof pitch. And this all thanks to the semantic segmentation model we've deployed that parses out parts of buildings and images to automate this attribute extraction. And we have a number of these models. Once we get into running Brailles, you're going to see that we have a good number of attributes built in there that you'll be able to use Brailles to get this data for. I'm just sort of here showing some of the under the hood sort of what Brailles uses and some generic sort of approaches that are implemented in Brailles. So one of the other approaches used in Brailles is what's called an object detection, putting basically bounding boxes around relevant image regions to figure out a certain attribute. In this specific case, it's the number of floors. These bounding boxes go around rows of windows to figure out how many floors there are in the building. And this gives us the flexibility of if you have a building with say 20 floors, there will be 20 rows of windows. So you don't actually train a model that sort of memorizes what a 20 floor building looks like. It actually looks for, what it should, the rows of windows. And here you can see if you're familiar with it, well, really based on performance, if we're able to pass in clean images into a model like this, we get about 95% accuracy in predicting the number of floors. But then, there's some complications to getting the images, and we, again, sort this all out under the hood in Brailles so that you don't need to deal with any of this. Some accuracy measures here just for reference. We do have another model that's able to predict the occupancy of buildings. Right now, it's at about 71% prediction accuracy. And this is work in progress, just another sort of approach. We do have a roof classification model. These are, by the way, test accuracies, all of these, not training accuracies. At the minimum, we've seen it do about 75% for classifying roofs into 3 separate categories. And we have miscellaneous things like, is there a garage in a building? What type of garage is it? And we have developed models for those too. And really the overarching idea of this is, think about that sort of higher level flow chart that or pipeline that I showed earlier. We couple the inventory data so that we can make predictions on what kind of losses to expect. This one's a test bed that we performed at SimCenter for Atlantic County. Using Brailles, we've generated an inventory of a little bit over 100,000 buildings. And we predicted what kind of loss ratios to expect for these buildings under combined wind and storm surge events. So the topic of this presentation, as I mentioned, is really just obtaining inventory data. But there's also another aspect of Brailles that will be useful to you all is, say you're interested in developing image classification, semantic segmentation, or object detection models, like the ones that I showed earlier, the GIF images for. Brailles actually, it enables a fairly easy to use interface to develop these kinds of models. It really works in a way that you put the data in, it optimizes everything it needs to in terms of training the model, and then you get the model out. So it takes away sort of like the required expertise, if you will, to develop these models. This aspect of Brailles I'm not going to be talking about today, but I just wanted you to be aware of it. If you're interested, we had a boot camp, an AI boot camp last year and the year before, where I talked about some of these aspects of Brailles, and these videos are available for you to see if you're interested later on. So that's sort of like the presentation portion, the slides portion of my my presentation today. So what I now want to do is really just jump into using Brailles, and we're going to run a few lines of code on the cloud to get this thing going. So I'm going to stop sharing my screen for just a second so that I can pull up the worksheet, the Colab notebook, the Jupyter notebook we're going to use. All right, so here it is. Here it is. So what we're going to do is I like running this on a cloud sort of based notebook. But really all this is it's a Jupyter notebook that you can download on your computer and run anywhere. For instance, on DesignSafe. Colab serves as like a convenient platform. That's the main reason why we're using it. And before I actually went on to give this presentation, I ran parts of this notebook. We're going to run them together. the main thing that you're going to see with Brailles is, the first time you run it, it will take a little bit of time downloading the models, because they're downloaded from a remote repository. So the first time, it's not Brailles that will take a long time. It will be downloading the models for Brailles that will take a little bit of time. And I noticed Colab's been a little bit slow today too. So downloading 3 of the I think 6 or 7 models that I needed took about 20 minutes. So we're going to do like a small implementation. I'm just going to jump right into the kind of file you're going to get. But let's get started with this demonstration. So the first thing we're going to do is we're going to pip install Brailles. Really, my suggested way of installing Brailles will be just pip install Brailles. Right. I have a typo there. What you can also do if you're interested, so what pip install Brailles will do is it will give you the latest, you can call the stable version of Brailles, or latest release of Brailles. But in between releases, we actually do update, the code base for Brailles. So if you're really interested in getting the latest greatest, but not the release of Brailles, you can also follow a syntax like this. What this does is it basically pip installs what's up in the GitHub repository of Brailles, which if you want to see where that is, it will be NHERI SimCenter Brailles GitHub, which pops up the GitHub repo for Brailles that has a link for the online documentation. Here's the pip install instructions. I realize I typed it lowercase, it should have been uppercase. And here's the example actually we're going to run through. And if you're interested, there's more Jupyter notebooks you can use here to basically tap into to run different components of Brailles. The one we're interested in today is the inventory generator, which is an end-to-end pipeline that really takes away the hassle of running these modules or models individually, basically figuring out where to get the images and so forth. It's an end-to-end pipeline that does all of that for you. So what I'm going to first do is I'm going to install Brailles. So you can disregard that warning message that I got. It was just saying I developed this in a high RAM environment, and it wasn't really. So let's just do. And it didn't like the comment that I had in there because it's technically a terminal command. What we're doing here has a hard time sort of parsing out in between those. Again, just like a Colab quirk, if you will. And what that's going to do is it's going to basically install everything needed for Brailles. Brailles runs on PyTorch. That's the deep learning library Brailles uses. It's fairly lightweight. We've really stripped away a lot of the sort of like the larger packages so that it's more efficient, it runs correctly. And then right away you're seeing my API key here, which I will delete after the session. So let me sort of get into this code. Let me try and explain it. And this notebook you'll be able to find in the GitHub repo for Brailles, and it does have a quick explanation of what is needed in this step to run. The first thing we're going to do here is Brailles is a Python package that we just installed using pip install. We're going to import the inventory generator methods from Brailles. And the way to do that is Brailles.inventory generator import inventory generator, like this line right here. And the syntax, the example syntax, which you can also find in the documentation or this landing page for this GitHub repo, is fairly simple. So there is 4 required parameters for you to be able to get the inventory data for a region of your interest. And there's multiple ways you can define this location. The one that I found the most useful for a lot of people is really just entering the name of the location. Brailles has an embedded method to, based on the name you enter, go and get the polygon for the region you defined. And you can define multiple locations here too. It will be just a list of multiple names here. And once it gets the polygon, it goes in and obtains the footprints for that location, and then sort of starts cranking up the inner workings of it, which is, goes ahead and finds the images, satellite and street level imagery for the locations, the footprints that were extracted, and then goes on and passes those into a number of deep learning models to figure out the attributes required by the user. And we'll talk about what those attributes are but before that, I'm gonna give a quick rundown of how we actually get the API keys. So this API key is a Google API key because Google is the main place where we obtain most of our street level and satellite imagery. It serves as basically an identification method for Google to determine, what account is accessing the necessary APIs for obtaining the images. And as I said, we're really downloading street level imagery and satellite imagery. And for that reason, we have to have those two APIs enabled on the Google console. So this is going to be a quick detour here, but an essential one, because although, Brailles is very simple to use, sometimes I find people actually spending more time figuring out how to use Brailles than you're really getting this API key. So I'm going to take maybe a couple of minutes to walk you through it. And for that, I need to, let's see. So I need to switch to another browser here. Let's see. Okay, let's try this one. I'm gonna stop sharing and move on to this new browser now. Okay. All right. So the first thing we're going to need to do is we're going to search for the website named Console Cloud. Okay. And it pops up a bunch of links here. The one you're really looking for is console.cloud.google.com. So if you click on that, this was my previous UCLA account, so I got to first log into it. Okay, so the very first thing we're going to do is I have a bunch of projects here that I've already created. Don't worry about any of this. So this landing page will look exactly the same for everyone. What you need to do is to go in here on the left, go to APIs and services, and click on credentials. So in case I went kind of fast, you click on the sandwich panel right here. APIs and services, and then credentials. And that's going to take us to basically this window right here. What we want to do is, I don't want to mess around with what I have over here. So let's see if I have another project. Maybe let's go to another browser actually. Let's try this one more time. Again, I'm going to repeat the steps that I began with. So console cloud, Google Cloud Console. My internet seems to be particularly slow today, so I appreciate all of your patience. Okay, and we have that same exact screen we saw earlier. So we click on the sandwich bar. Oh, there we go. Okay. APIs and services and credentials. Again, I apologize for the how slow this is loading. And it's not doing so well today. All right, there we go. So I already have an API key loaded here, and that's the one you actually saw on my collab, which I will remove after this session. But let's just create another one just to go through the exercise. So we hit create credentials, and then we hit API key here. And what that's going to do is it's actually going to create the API key you need. So a lot of times people think it's okay now that they have the API key, it's okay to stop and you're good to go. If you copied and pasted this API key into our collab notebook that we saw earlier, you actually won't be able to run Brailles because we still need to enable the necessary APIs for Brailles to run. And those are the Street View API and map static API. So what I typically do is then, I hope I didn't go too fast. So on the same menu bar, I clicked on the enabled APIs and services. And now I'm going to click on enable APIs and services here. And what I'm going to do is I'm just going to type in static in here. And because I've done this so many times, I know exactly the right keyword to enter. So these are the two APIs that we're going to need to enable. What I'm going to do is right click and do one of them, enable one of them for now. Actually, maybe we'll do both of them since my internet is too bad. Okay, so mine already says API enabled because I've enabled it for my previous API key, which automatically transfers over to the new API key. But what you're going to see is a button that says enable API. So you click on that, and then you're going to see this check mark right here. And then you're going to need to do that for map static API and Street View static API. So if this step, doesn't seem clear, this is a recorded session. You can come back to it and follow along the steps. But one thing that we built actually in Brailles is Brailles does have a way to determine if you have the necessary API keys enabled. So what Brailles will actually do is if the API key you entered here doesn't have the, say, like the static maps API enabled, it will actually tell you what API you're missing. If you're missing both, it will tell you exactly what APIs you're missing. And if it's, if everything's well, if everything's good, then it will just run one like you would expect it to. So that's the API key here. That's the sort of this long string entered in here. And the only purpose of that is because we need images, we need a method to download images, and we found the most consistent one is Google APIs. The rest of the selection here is fairly straightforward. this is a test run that I did for Santa Monica before I, started the session. For Santa Monica, this is, in case you're not familiar, it's a city in Los Angeles. The inventory generator is able to find 23,511 buildings just by entering the name of the location. It again gets the polygon for the location, and it extracts the building footprints for that location. So what sometimes you might typically want to do is, if the inventory for the location you're interested in is too big, you might want to do it in batches, because remember, for 23,000 buildings to get an inventory for it, you're going to need to download 23,000 images, probably times 2. For satellite, you're going to need to download satellite images and street level imagery. So what number of buildings does is it basically caps it at a certain number. If you want to, just test out inventory generator, this is a great sort of way to do it. If you really just are interested in random 100 buildings in a city, this is a great way to do it. It's a good sort of way to maybe get started with Brailles, or just limit your query to a small number of buildings. And then if you want to keep the same buildings get the same buildings over and over again for the same query, all you need to do is to hit random selection and type it false. And if you want different buildings each time, you can just set random selection equal to true. So now, I guess you can argue this was maybe the most important component, but really, for you to generate inventory data for a location, all you really need to do is to enter the location you're interested in. So I started with Santa Monica, California, because I lived in Santa Monica, California for so long in Los Angeles, but this could be really any place you would like. We can type Berkeley, California.
Barbaros, while you're here, there was a question: could this be anywhere in the world?
This could be anywhere in the world, yes. So this this location extraction and the footprint extraction basically right now is coded for anywhere in the world. There could be places where the footprint data could be limited. It might not reflect the entire area you're interested in. So there could be gaps in the footprint data. But other than that, this should be available to use anywhere in the world. I can maybe see issues with Street View imagery not being available everywhere, but the API will run, and if it can't find a Street View imagery, it would just put a not available in your inventory table. But this step should run irrespective, as long as you have an API key and you enter a location that is decipherable by this algorithm. And you don't need to have strict punctuation. It's pretty good at deciphering locations. So yeah, it is it can be used anywhere in the world. And you can see, sorry, Frank, did that answer the question?
It did. Now there's another one, I guess. While we're here, can they specify coordinates to a region as input?
Yes. Yeah. So you can one way of going about location is actually entering the name for that location. But another way to do it is enter the coordinates. I can't really come up with coordinate numbers off the top of my head, but I'll just say lat 1, long 1, and then lat 2, long 2. If you provide a list like that with basically the vertices for the edges of your region, you'll be able to run Brailles without defining a name. You could run it really for like a rectangular grid, an area that you decide that you want the inventory for. And then other thing that I mentioned, if you say know like names of multiple villages that have small amounts of buildings, you can also do. I'm not gonna run this because it's going to be a long query. You can do Berkeley, California, and then you could go Santa Monica, California. This would be another way of doing it. And then you've noticed my punctuation is not right, but it's not a problem. It should just run fine. I guess we can try a random location. Just gonna say I don't have anything for Germany. I just Berlin, Germany. Let's see what comes out. I forgot to remove the square bracket here. Yeah, see, you can right away deciphers the query and then writes Germany and German language, Berlin, Deutschland, and then goes ahead and fetches the footprint data for it. I believe this is a fairly large size city, so that process might take a little bit longer than it did for Berkeley and Santa Monica. I'll just wait for a few more seconds, and if it doesn't get us a response, I'll just stop it there. Okay, I'm going to stop it just for the sake of time, but if you are more patient than I am, it should run just fine. So I'll go back to Santa Monica, California. I'll let it run, and then I will move on to the next slide right there. Okay, so one of the questions from earlier was on what are the attributes available in Brailles for us to use. So the answer to this question is Brailles is fairly dynamic. It's an ongoing project, and a lot of our models, although matured, sometimes we occasionally take them out for regular maintenance and then replace it with a new one. The best way to figure out what attributes are currently enabled in Brailles is to use the syntax right here. So remember, up top we've generated this class object called imGenerator, right? So down here we're going to call that imGenerator with an enabled attributes method to figure out what attributes are available in it. So if I click on that, it will tell me building height, chimney, area build, garage, number of stories, occupancy, roof eave height, roof shape, roof pitch, construction type. I think I saw a question on is Brailles able to figure out first floor elevation? It is. That functionality is temporarily taken out. I'm working on improvements on it. So that's something Brailles is able to do. And then another one that's taken out that I can think off the top of my head is roof cover. We've trained a fairly well-performing model just recently, but I'm working on some adjustments to it. So that one's another one that's taken out. So in the current version, if you're not sure, just basically run this method to find out what attributes are available. And if you're thinking, hey, like I've already downloaded all these images for these buildings, so why cap at a few attributes? Let's just do all of the attributes. All you need to do is you figured out what attributes you want and you want them all. You go ahead and call inventory generator with the generate method, calling attributes equal all, and this will start basically cranking up the image download methods and passing them into the deep learning models to figure out what those attributes are. I think I'm gonna actually start running this like that. What I like to do is maybe what I noticed is Colab's been internet on the Colab side has been particularly slow, so we won't be able to run for all of these attributes. I'm just going to show you what an output looks like, basically. That's compatible with R2D. But you can also, another way of sort of calling the Brailles to generate inventory is you can define a list of attributes that you're interested in. Really the only reason why you would do this is maybe you're on a time crunch and you want quickly just 2 of the fields out of all of them. Then there's a list like that. Like for instance, I've run it just for construction type, so that I can show you guys a table that has the outputs, right? So we can get this sort of cranking by hitting the run button, and I'm gonna let's see, what do we need for we need these. Okay, let's see, we wanted to do some sort of like a basic earthquake loss assessment type of thing, lump mass models, etc. I guess these are the attributes we would need. So I'm just going to run it for these. I'll just let this run for now. And right away, what you're going to see is it's going to start walking you through what it's doing. It's going to say, detecting number of floors for each building, loading the full floor model, blah, blah, blah. So what's going to happen for you, and I think for me too, is this downloading will take a little bit of time. And if you're running on Colab, that's just, you know, internet being slow, I think, on either my internet or whose internet, I'm not sure. But typically, these models are downloaded in less than a few minutes, and then runtime for like 20 buildings is maybe 5 or 6 seconds. So really the big chunk of downloading the models will be, the big chunk of the runtime will be downloading the models. And it needs to do it for building height, area built, number of stories, and construction types. So 4 models will be downloaded separately. We'll have this running, it will run for a while, just be patient with it. And then what's gonna happen next is, once this runs, you can, again, come back to that inventory generator method and call it with the inventory method to see what the output looks like. So you can see this one sort of shows you where the images are stored, for you know, that they're used to make the predictions. It gives you the polygon for the footprint of the building, the area of the footprint calculated, and these are all in American units. Number of stories, building height, construction type. It looks like I hit pretty much a residential area here. Most of Santa Monica is. And then era built. So one thing that's important to tell here, we don't have the capability to predict year of construction at you know, individual year levels. So really, this is that's why we call it the era built. So if you see the year 1975, it really means that that building was predicted to be built between 1970 or 1980. We put in this number so that R2D can actually have a year output that it can you know, use to predict things. And then once that's all done, if you run this on your local computer, you will actually see a CSV file created. And because this is still running, I won't be able to run this command. But if you want to get the CSV file, you can basically use this command from Google, call app files download inventory CSV. That's the typical name it would save it under. And then if you're interested in, you know, if the predictions are good, you can take a look at the images. This is sort of like a code snippet meant to do that. And then if I went too fast, you can always come back to this video, obviously. But if you had a hard time maybe catching up with some of the code, come back to notebooks and then run the sample collab call notebook here. Okay. And that will basically, get you through the whole process.
Now, the last thing I wanted to show is the CSV file generated by Brailles. So I'm gonna pull that up really fast. Okay, so this is the inventory.csv file created by the inventory generator by default. So this would be saved under your current directory when you're running it locally. And using the syntax that I showed a little bit earlier, you can also download it on your local computer if you use a service such as Colab. Sort of quick rundown of what we're seeing here. So the CSV file is built to be compatible with R2D. So the first column has the ID numbers generated sequentially for the 20 buildings we've randomly selected. Columns for longitude and latitude and longitude, the plane area, number of stories, building height, structure type, year built, and occupancy class. These are all the attributes we've generated, and basically Brailles wrote them in a way that will be compatible with R2D. So this file is basically good to go with R2D. Since we're running kind of out of time at the moment, we won't be able to import this in R2D and do a quick run, but feel free to follow the examples uploaded on the SimCenter website to do your sample R2D run. This inventory file should be good to go to use with one of those examples. And this basically concludes our tutorial. Thank you very much for your attendance.